back, and this is where I had left you after that statement number 1, and I had asked you to think how to get that right hand side ratio, and I know you would have got it. Let's see how you would have got it. Right? When you look at the numerator AE, now the first question is, does that AE belong to a triangle? Yes, it belongs to a triangle, that is triangle ADE. Now for that triangle ADE, can AE be the height? No, it cannot be the height. Why? Because it is not a perpendicular segment, right? So now that AE, will that be the base of the triangle? Yes, it will be the base now. Now the same way, now when we consider EC, the denominator, now EC, can that be the height? No, because it is not a perpendicular segment. That means EC is also the base of that triangle, of another triangle rather, right? Now AE and EC, these are the two bases which you are going to consider. AE is the base for triangle AD. If AE is the base, the height should be drawn from where? It has to be from D, and we draw that height now, that is drawing that DN perpendicular to AE. That happens to be the next construction which we have, right? Correct? Now the same way, what we do is for EC to be the base and DN to be the height of a triangle, to create the next triangle, what should we draw? We need to draw that segment DC, and that is the next construction which we write there, right? So now we know the two triangles. One is triangle ADE. So for that, what is the area? It is half into AE into DN. And for the next triangle, what is the area? It is nothing but half into EC into DN, right? Now, wasn't that easy now? Till now we got half into base into height, that is half into AE into DN, and the next one which we got is nothing but half into EC into DN. Simple? Beautiful. Now we divide it, right? Now when we divided the numerator and the denominator, we get half and half cancelled, and DN gets cancelled. So we have area of triangle AD upon area of triangle CD is equal to AE upon EC, and that happens to be our statement number 2. So now what has happened is, both the ratios, the left hand side ratio we got in statement number 1, the right hand side ratio we got in statement number 2. Now only thing is, we need to get this equal. Now when we want this to be equal, now, right, if you observe this in these two ratios, right, rather than in statement number 1 and statement number 2, if you want the right hand side to be equal, you need to get the left hand side equal. And now if you see the left hand side, the numerator of the first statement, the left hand side, area of triangle AD, and the next statement, area of triangle AD, it is same. Only now the denominator, that is area of triangle BDE there in the first statement, and area of triangle CD, this is what we need to get equal. That means if we get this equal, we are getting the left hand side equal. And once we get left hand side equal, we'll get the right hand side equal. Hence we get the proof. So somehow we need to get area of triangle BDE and that area of triangle DCE to be equal, right? So if you look at those two triangles, that is triangle BDE which I've highlighted there, and the other one that is triangle DEC, we want the areas of this to be equal. If we want the areas to be equal, we need to get the heights and the bases to be equal for both the triangles. So if you observe that, we have been given that these two triangles are between the two parallel lines. Observe, because we have line and L and BC to be parallel, right? So that means these two triangles lie between the same parallel lines, and that means the heights are equal. At the same time, do they have a common base? Yes, they have a common base. That means they have a common base and their heights are equal. That means we can say that these two areas or these two triangles will have equal area. That means area of triangle BD is equal to area of triangle CDE, which we wanted there, and we get that. And we know the reason, that is nothing but if two triangles are between two parallel lines with a common base, then their areas are equal, and that will be a statement number 3. You know what has happened now? Observe very carefully. This, from statement number 3, we have got area of triangle BDE equal to area of triangle CDE. That means the denominator of the left hand side of the first statement and the denominator of the left hand side of the second statement are equal. That means now from 1, 2 and 3, we come to know that the left hand sides are equal. So if the left hand sides are equal, what happens? The right hand sides will also be equal. That means we would get AD upon DB is equal to AE upon AC, and this is something which we get in the proof. The reason would be from 1, 2 and 3, and we get the proof done. Wasn't that easy? A simple proof. Very, very, very important, but